So the first one, the example which I have taken, it is a sphere of diameter, a sphere of diameter 50 millimeter rests centrally on the top of cube of size 50 millimeter. So we have to draw the isometric projection of this combination. So what exactly is given? A cube is the base solid. Above that, a sphere is placed. That's what he has given. A sphere of diameter 50 millimeter rests centrally at the on the top of cube of size 50 millimeter. First, we have to draw the base solid, that is a cube. Above that, we have to draw the sphere. A sphere is nothing but it's a ball. Okay, the ball is so nothing but your the sphere. So here also, before proceeding to the actual isometric the projection, so we need to draw the top view, preferably top view as well as the front view of this combination. So assume that you have placed a cube. Above that, the sphere also you have placed. So if you see this the combination of the solid from the top side, your cube will look like a square, correct? And your the sphere will look like a circle. So that is what I have written here. First you draw the xy line. Below that you draw a square, because the cube will look like a square in the top view. You draw a square of 50 millimeter. Okay, like this. You can draw a square of 50 millimeter like this, and then after that, so we have your the sphere will look like a circle, right? And the center of your sphere and the center of your the cube are same. That means they are coaxial. So that's why how to take the center of the your cube, draw the diagonals. Light diagonals you can draw. So this is the center of your the cube at the axis. Now, so you take your compass, this intersection as the center, and what is the diameter? The diameter of your sphere 50. You take 25 millimeter radius. So with this intersection as the center, you can observe the cursor. You draw the circle. So exactly. So the circle you will going to get within the square. So this completes your the top view. Okay. So the base solid is cube. It look like a square in the top view. The above that a sphere is placed. A sphere will look like a circle in the top view. And coming to the front view, you draw the vertical projectors like this in point and from the center line also. So your cube, when you see from the front side, it look like a square only, because in cube all the three dimensions are same: length, breadth, and even height or the thickness. So what you do? So from the center, so you take 50 millimeter height and then construct this one more square. So above that, the sphere is placed. In sphere, the speciality of your sphere, in whichever the view you can see a sphere, it look like a circle only. So 360 degree also, if you see a ball, okay, it look like a circle only. So that's why how to draw the sphere in the front view above your cube in the sense. So extend this axis line, extend the center line or the axis line. So what is the radius of the sphere? 25. So from this point you take 25 millimeter, the same vertical line, and mark it. So that is the center for your the sphere or the circle. Now, so you take same 25 millimeter radius and draw the circle like this. Draw the circle with the center which you have taken 25 millimeter above this center line. So I hope you understood both front view and top view. After drawing this, so I need to draw the isometric projection first, the cube, because that is the base solid. Above that, I need to draw the isometric projection of your sphere, which is placed exactly above your cube. So let me explain in the next slide. The first what exactly I'll do, because these things you know. So I'll take any one horizontal line to draw the cube, and take any one of the point on that horizontal line, and I'll draw 30-degree line on either side. I'll draw a 30-degree line on either side, and now I'll take the cube, the dimension that is 50 millimeter. You convert that into isometric scale. Now whatever this the dimension I'll speak, it is isometric dimension only. Okay. So you take 50 millimeter isometric scale dimension, cut on both the sides of your 30°. So after getting these 2 points, you draw a parallel line to this and parallel line to this, a 30° line left and right. Wherever these two lines the coincides, so you will going to get this point. So base of your the cube is ready. So after this, what you have to do? The next step which is given here, from all the four corners of your the base of your cube, you draw a vertical line like this, 1, 2, 3 and 4. Draw a vertical line. This vertical, the line height should be equal to the height of your the cube. What is the height of your cube? 50 millimeter. You take the isometric 50 millimeter the dimension and cut it in all the four this vertical line you are drawing from this corners. Okay. After this, you join all these endpoints of this line which you have drawn. Your the cube is ready like this. So after drawing vertical projectors, you join all these 4 points. So your cube is ready. That means bottom the solid is cube. The cube isometric projection is ready with me. So now above this, that is top face of your cube, I need to place a sphere above this. So we'll discuss how to place a sphere about it. Okay, above it. So first let me draw a diagonals from the top face of your cube, so that to find out the center of the top face of your cube. So this is the center of your the top face of your cube after drawing this diagonals. Okay, so this is very simple. After finding out a center, from this center you have to take this vertical line. In this vertical line you have to take the axis height of your this sphere. What is the radius of the sphere? Actually it is 25 millimeter, correct? So you convert that into isometric scale. From this the intersection point and this vertical line, you take isometric 25 millimeter and mark it. So exactly you may get somewhere else here, okay, at the corner itself. Okay, you find out that. So now you take this as the center. You take this as the center to draw the sphere. Because as I told, even in the isometric projection also, the sphere will look like a circle only. That's what I told. The sphere, in whichever the angle you see, okay, so it look like a circle. So that's why. So sphere, even if you tilt in any direction, it will look like a circle. This what told you. And also the one important note that you have to note here means, only for the sphere, while drawing a sphere, you have to draw the actual scale of the sphere, not the isometric scale. Except the sphere, for all other the drawings we have to take isometric scale only, because the ball, in whichever the angle you are tilting it, it look like a ball only. So there is no reduced length you are going to get. So for this, so you have to take the center only for this height. From this intersection, the radius of your the sphere you have to take, that is 25 millimeter isometric height you have to take. From this center, actual radius of the your sphere, that is 25 millimeter actual radius, you have to draw the circle like this. If you do this, this completes your isometric projection of the cube above which this sphere is placed. Now the next question arises, how to darken the visible edges. The next slide I will show you. Here you can see. So this complete portion you can see, the bottom the base of your cube, only these two you can see. Top face till here you can see. So this completes this sphere you can see like a circle. So 1, 2, 3, 4, this and this and this and this should be a so now onwards what you can do it, okay, so you can remove these hidden edges, or that the edges that we cannot see. You can erase these edges so that only the visible edges we can see. Here just to explain you, I made these lines a thin line, so you can erase these thin lines which are drawn here, so that only the visible edges you can make it thick. to show the combination of the isometric, the projection of these two solids. So this is the procedure that you have to follow to draw the isometric projection of the combination of solids. I hope you understood this. So I'll take one more example of this, the combination of solids. So in this example, what exactly is given? A square prism of base side 40 millimeter and height 50 millimeter is placed centrally on a rectangular slab, sides 100 millimeter by 60 millimeter and thickness 20 millimeter. Draw the isometric projection of the combination of solids. Here the base solid is the rectangular slab of 100 by 60 millimeter and the height is 20 millimeter. Above that, the square prism is placed, the side is 40 millimeter and height is the 50 millimeter. Okay, so you place, assume that you are placing a rectangular slab, above that a square prism. So when you see from the top, the rectangular, the slab will look like a rectangle. What is the side of the rectangle? 100 by 60. After drawing XY line, you draw a rectangle of 100 by 60 like this. So you can observe this cursor. So your square slab, rectangular slab look like a rectangle of 100 by 60. You draw a outer rectangle first. Next, your square prism will look like a square in the top view. So you have to, and the center of your the square prism and center of your rectangular slab should be same. How to do this? So for this, so what you have to do after drawing the outer rectangle 100 by 60, you to find out the center, you draw the diagonals like this. So this is your center. Okay. So after drawing this center, so what you have to do? So what is the square dimension? What is the square dimension? What is the dimension of this square? It is 40 millimeter side. A square of 40 millimeter I have to draw. So after that, what you can do here, I am not shown here, just observe it. You draw the horizontal line as well as the vertical line passing through the center. Just observe this, once again I will repeat it. From this center, you draw the horizontal line as well as vertical line passing through the center, which I have not mentioned here. So after this, what you have to do? Square from the center, if I consider, so exactly divides, that is 20 millimeter you are going to get, correct? So what exactly you have to do now? From this center and this horizontal line, 20 millimeter you take right side, left side, and 20 millimeter you take right side and mark it. Similarly, the vertical line, you take 20 millimeter and mark here and 20 millimeter mark it here. So all the sides 20 millimeter you mark. After marking all these 4 points, you draw from this marked point, you draw the horizontal line. Here, whatever 20 millimeter you have marked, you draw the horizontal line. Right side 20 millimeter, whatever you have marked, you draw the vertical line from here. From left side, the 20 millimeter, whatever you have marked, you draw the vertical line. Wherever this vertical line and horizontal line intersect, so you highlight only this square. So that is nothing but your square, which is placed exactly at the center of your rectangle. So this how you have to draw the square in the top view. It is a coaxial one. The center of your square should be same as that of your center of your rectangle. I hope you understand this. So afterwards, when the same combination of solids, if you see from the front side, your rectangular slab will look like a rectangle. Only height I can show. And your square prism also will look like a rectangle. How to draw this? You draw the vertical projector from all the points like this. What is the height of the base solid? That is rectangular slab. 20 millimeter you take and construct this rectangle of the 100 by 20. And what is the height of your the square prism? 50 millimeter. Now you take 50 millimeter, draw a line, and then from here, this is a prism now. You extend this line till here and construct this one more rectangle. That is nothing but your the square prism. Okay, all of you understood this. In the top view, the rectangular slab will look like a rectangle of 100 by 60, and the square prism look like a square. And in the front view, rectangular slab will look like a rectangle, and your square prism which is placed above the rectangular slab will also look like a rectangle like this. Okay, so once you complete this both top view and front view, next we'll go to the isometric projection of this combination. The first, let me draw the isometric projection of the base of the solid, that is a rectangular slab. So rectangular slab which is given, it is 100 by 60. So what I will do, I'll draw an horizontal line. I'll take any one of the point. I'll draw 30-degree line on either side. One side I'll take 100 millimeter isometric length and cut it here till here, and other side, left side, I'll take 60 millimeter isometric length and cut it here. After this, I'll draw a 30-degree line in this direction or parallel line 30-degree in this direction. Wherever this intersect, the base of your rectangular slab is ready with me. What is the height of your rectangular slab which is given? It is 20 millimeter. So after this, so what you have to do? You have to draw a vertical line from all the 4 points, that is height, which is equal to the isometric, the length of 20 millimeter. So how to draw this? Let me show you here. So like this, you have to draw a 20 millimeter vertical line from all the 4 points, because this is the height of your rectangular slab. That is isometric 20 you have to draw. After drawing all the 4 vertical line which is equal to the isometric the height of your rectangular slab, you join this 4 points like this. So one more rectangle you are going to get like this. You're going to get one more rectangle like this. So now this is the isometric projection of the rectangular slab, that is a base solid which is given over here. The base solid, so which is a rectangular slab of 100 by 60 and the height is 20 millimeter. This completes the base solid. So above this, exactly at the center, we need to place this square prism. Correct. How to find out the center of this top of your rectangular slab? Draw the diagonals like this. Once you draw the diagonal, you're going to get the center. Above this, I need to place the square prism. After drawing this, the diagonals, after finding out the center, so what you have to do, the next construction line is, from this passing through this center, you draw a parallel line to these two lines from here, like this. The pink line which are drawn here, passing through the center, which is parallel to 100 millimeter on either side of this 100 millimeter line, rectangular slab. And I'll draw one more, the pink line you can see from here. So this is parallel to the 60 millimeter of the rectangular slab. So this is the construction work that you have to do it. Once again, I'll repeat it. So after finding out the center of your top face of a rectangular slab, you draw passing through the center, draw a parallel line like this to this 100 millimeter line, and draw a parallel line passing through the center to 60 millimeter line. Draw it. And what is the size of your square prism? The side, it is 40 millimeter. Correct? The 40 millimeter means from the center, if I consider, means on both the sides 20 I should get it. Correct? So what you do, since it is a square, from this center and this the parallel line whatever you have drawn, so from all the sides 20 millimeter, isometric 20 millimeter. You mark isometric 20 millimeter here, isometric 20 millimeter here, isometric 20 millimeter here, and isometric 20 millimeter here. Mark it with the help of the compass. That is what I have done here. So after doing this, after finding out this the point and this parallel line that you have drawn, now what you have to do after this, you from this end point as the reference, you need to draw the parallel line like this. From this end point, you draw a parallel line to this. From this end point, you draw a parallel line to this in this way, and from this end point, you draw a parallel line to this in this way. From this end point, you draw a parallel line to this in this way. Let me show it in the next slide. See, so in the previous slide till this end point, so you are marked. Now from this point, you are drawing a parallel line to this. From this end point, you are drawing a parallel line to this. From this end point, you are drawing a parallel line to this, and from this end point, you are drawing a parallel line to this. So this is 20, this is 20, total 40 isometric length you are going to get. this is 20, this is 20 total, 40 millimeter. That means done this construction were to fix the base of your square prism. The base of the square prism is ready now. So this is the base of your square prism. Okay. What is the height of your square prism which is given? The 60 millimeter. I think from all these 4 points, that is base of your the square prism, you draw the vertical projector like this from all the 4 points, and that height of that should be equal to the height of your square prism, it is 60 millimeter. Next slide, let me show you. 50, height is 50, it is given. So you draw the vertical projector from all these points, that should be equal to the isometric length of the height of your square prism, that is 50 millimeter. After finding out these points, you join all these 4 points. So you're going to get like this. If you join, you're going to get the square prism. So now, so this is the combination of the rectangular slab. Above that, centrally your square prism is placed. At the end, you need to identify the hidden edges as well as the visible edges. So coming to the visible edges, so this complete portion, whichever is nearer to you, you can see, and the top face still here you can see, and here you can see, and this is the bottom of your square prism. You can see the complete top face. You can see this line, whichever the lines which are marked with the light line that you cannot see, you can erase those lines. Only you can retain the, so the for the bottom solid, the black color whichever highlighted with a thick line, so that is the visible edges. For the top solid, for the square prism, so whichever the line are marked with dark pink color, so that is your the square prism which is placed above that. Rest of the lines you can erase it. Okay, so this how you have to draw the isometric portion of the combination of this rectangular slab above which the square prism is placed. Okay, I hope all of you understood this. The same procedure is followed. Only thing is I'll be changing the combination of the solids. That's all. Okay. So let we move on to the next the combination. Here it is very simple because in many cases we have discussed this. That means in this case, just read out this. Two cubes of sides 60 millimeter and 40 millimeter are placed centrally one above the other in the ascending order of their side. Draw the isometric projection of the combination. So what exactly is given means the two cubes are there. One cube is having a dimension of 60 millimeter. Another cube which is placed above that, it is placed centrally above that, which is having a dimension of 40 millimeter. So that means the two cubes which are placed one above the other in the ascending order is given. So that's my, so I will take the bottom, the solid as the 60 millimeter the cube, above which the 40 millimeter cube is placed. So before proceeding to the actual isometric projection, so let me show you how to draw the front view and top view. So once you draw the explain below, so the bottom, the cube will look like a square in the top view. Correct. What is the dimension of the bottom cube? It is 60 millimeter. You draw the 60 millimeter square. And what about the one more cube which you have placed above the 60 millimeter cube, that is 40 millimeter cube? It will also look like a square only. So that means both the cubes in the top view look like a square only. So that means after drawing this outer square, that is 60 millimeter, you draw the diagonals, which I have not shown here. You draw the diagonals like this. Find out the center. After finding out the center, you draw the horizontal line and vertical line. So what is the size of your top cube? 40 millimeter. From the center, if I consider half of that, from this center you take 20 millimeter here, 20 millimeter here, mark it, and similarly 20 millimeter above and 20 millimeter below you mark it. So wherever you mark, and this the horizontal line and vertical line, now you draw the line like this. like this and that marked line. So whatever the square that you are going to get inside after projecting those lines, so this is your square which is uh, coaxially with your the other square, that is, so both the squares are coaxially which are placed both the cube. That's why this how you can draw the square within the another square. So after drawing this top view, so you project this upwards like this. After this, the cube in the front view also you look like a square only, correct? So from here you take the height of the cube also 60 millimeter only and draw a square of 60 millimeter. Now center line you extended above this 60 millimeter cube, 40 millimeter cube is placed. From here you take 40 millimeter height and construct one more square. You have to draw these two lines here. So you will going to get the one square is placed above the another square like that. In the front view you will going to get like this. So this how you have to construct the top view as well as the front view. Next we'll go to the isometric projection. So first I'll draw the isometric position of the bottom solid, that is a 60 millimeter cube, correct? So I'll draw an horizontal line, I'll draw a 30-degree line on either side, and I'll take isometric 60 and cut it on either side. After getting this point, I'll draw 30-degree line in this direction, 30-degree. Wherever these two lines intersect, I'll going to get one more point. So the base of your cube is, bottom cube is ready. How to draw the cube now? So height of the cube is also 60. You take isometric 60 vertical line from all the 4 points like this. You draw. I'll show you in the next slide. So like this, isometric 60, you draw from all the 4 points. After that, you join all these end points like this, the pink color line which I have shown here. So this completes the isometric portion of the bottom solid, that is a cube of 60 millimeter. Now above this, I need to place one more cube which is having 40 millimeter side. So before that, what I have to do it, I need to find out the center of the top face of your cube. How to get the center? Draw the diagonals like this. This is the center of your the bottom the cube. Above this, coaxially, I need to place one more the cube of 40 millimeter side. Correct? Let me show you the next slide here. As usual, the previous example, whatever we have done, after just observe the cursor, after finding out the center, after drawing the diagonals, so you from passing through the center, you draw a parallel line to these two lines in this way, and from passing through this, draw a parallel line passing through this like this, parallel line to this and parallel line to this. So this is, these two are the parallel lines that you have to draw passing through the center. This line is parallel to this and this edge, and this line is parallel to this and this, like that you have to draw it. Or else in simple in your language, 30-degree line. Okay, this is 30-degree line. So in simple words, how we can understand, from this intersection you draw 30-degree line on either side like this. In simple words, after drawing 30-degree line like this, what is the side of your the top cube? 40 millimeter. Half of that means how much? 20 millimeter. You take 20 millimeter isometric length. You take 20 millimeter isometric length from this the intersection point. You mark it on this 20 millimeter here, 20 millimeter here, 20 millimeter here, and 20 millimeter here. Mark it. So you're going to get 4 points. You're going to get 1, 2, 3, and 4. After getting these 4 points, from this point you draw a parallel line to this or 30-degree line. From this point parallel to this or 30-degree line. Okay. From this point you can draw a 30-degree line or parallel to this. From this point you can draw a 30-degree line like this or else parallel to this. So once you draw these lines, so you will going to get one more square inside like this. Okay, so the blue color which I have drawn here, so this is the base of your the top cube, that is 40 millimeter cube. Once you get the base of this 40 millimeter cube, from all these corners you have to draw the vertical projector line which is equal to, what is the height of the cube? It is 40 millimeter only. So next slide, let me show you. So you draw the vertical projector line from all the 4 base points. That should be equal to isometric 40. After getting all the 4 points, you join it from here to here, here to here, here to here, and here to here. So this completes the isometric projection of the combination of solids, where one cube is placed above the another cube, that is 60 millimeter and 40 millimeter combination. At the end, so you can retain the visible edges. See, the visible edges in the pink color, the dark lines which are shown here, that is the visible edges of the bottom cube, and here the blue color which I have highlighted with the dark color, this is the visible edges of here the top cube, and this also you make a note here. I have forgotten to make it thick, so this particular line also you have to make it thick. The rest of the lines, just a construction line here I have shown you, you can erase those lines. So your combination of this particular combination is ready with you. So in all the cases I'm using the same the method or the procedure. Only thing is, in each and every example I'm changing the combination of the bottom solid and the top solid. This so the combination of the two cubes which are placed in one above the other is drawn like this. We can able to draw. Next, so one more we'll discuss today. So after this I'll stop. So the next exercise which is given here, it is a rectangular pyramid. So pyramid I have taken an example now. A rectangular pyramid of base 40 millimeter by 25 millimeter and height 50 millimeter is given. And it is placed centrally in a rectangular slab of side 100 by 60 and thickness 40 millimeter. So you know how to draw the rectangular slab in the second example we have discussed. So you know how to draw the rectangular pyramid also. So we will see. So the bottom solid is rectangular slab of 100 by 60 millimeter and height is 40 millimeter. Above that, centrally a rectangular pyramid is placed, that is 40 millimeter by 25 millimeter side, and the height of the pyramid is 50 millimeter. So when these two combination solids are placed one above the other, the base solid rectangular slab look like a rectangle in the top view. Correct? So what is the rectangular slab? The dimension 100 by 60. So first draw the rectangle of 100 by 60 like this. This is 100 and this is 60. Draw the rectangle, and your rectangular pyramid, when you see from the top, it look like a rectangle. Correct? So how to draw one more rectangle? Within this rectangle, draw the diagonals and find out the center. Here I have not done that. From this outer rectangle, you have to draw the diagonals and find out the center. After finding out the center, you draw the horizontal line and vertical line passing through the center. Okay? So after that, what is the size of your the rectangular pyramid? So base 40 by 25 millimeter. So what I will do, on this horizontal line, so 40 off means 20, 20. 20 on either side I'll mark. Here I make it. Okay. And 25 millimeter, half of that means how much? 12.5. And this vertical line, 12.5 here and 12.5 here I'll take and mark these 2 points. How many points you are getting? 1, 2, 3, 4. After getting these points, passing through this point, you draw a horizontal line. Passing through this point, you draw a horizontal line. Passing through this point, you draw a vertical line. Passing through this point, you draw a vertical line. Wherever these the projectors meet, so inside you are getting a rectangle. This is your the rectangle of your the pyramid base. Okay. So after this, you draw the vertical projectors from all the points. So your rectangular slab in the front view, how it looks? It looks like a rectangle only. Only height we can take. What is the height? 40 millimeter. So you extend the end points here. Take 40 millimeter height. Construct one more rectangle. Above that, the rectangular pyramid is placed. So this you can extend till here. What is the height of the pyramid? 50. Correct. From the center, you take 50 millimeter. Mark this point. So this is the vertex or the apex of your pyramid. From this vertex or the apex, you can join here and here. It look like a isosceles triangle. The pyramid look like an isosceles triangle in the front view. So this how you have to construct the front view and top view. Now let me start with the isometric position of this combination. First, so as usual, so I'll draw the isometric position of the rectangular slab, the base solid. First, I'll draw the horizontal line. I'll take any one of the point here and I'll draw 30-degree line on either side. One side 100 millimeter I'll take isometric 100 millimeter and cut it. Another side isometric 60 I'll take and cut it. After this, I'll draw 30-degree line like this and 30-degree line like this, which I have not shown here. After this, from all the 4 points, you take the height of your the rectangular slab. How much? 40 millimeter. You take height on this vertical line, and here also one more point you will going to get that I have not shown here. From here to here you may get. Now after getting those isometric vertical line 40 millimeter, you join this all 4 points. So your rectangular slab isometric position is ready. That is the bottom solid is ready. So how to place a rectangular pyramid? About that, first we need to find out the center of the top of your rectangular slab. How to do it? Draw the diagonals. You will going to get this center. After getting a center, from this point center you draw the 30-degree line are parallel to this or this. Similarly, from the same center you draw 30-degree line in this direction are parallel to this or this. Draw it, and then after drawing it, so what is the base of your rectangle? The rectangle pyramid 40 by 25. So here if I consider 40, so from the center how much we have to consider? 20 on either side. So on this, the line which I have drawn, you take 20 here and 20 here. Observe the cursor. 20 you take here and cut it, and 20 you take and cut it on this parallel line. And similarly 25 means half of that 12.5. From this point you cut this 12.5 and 12. All are isometric scale. So you're going to get 4 points, 1, 2, 3 and 4. So from this point you draw 30-degree line are parallel to this line. Draw a 30-degree line like this. From this point you draw 30-degree line are parallel to this line. From this point you draw 30-degree line are parallel to this. Similarly, from this point you draw 30-degree line are parallel to this. So wherever this all those parallel lines intersect, so you will going to get one more rectangle. This is nothing but your base of the rectangular pyramid. The base of the rectangular pyramid is ready. Okay, which coincides with your rectangular slab center. Now from this center, so pyramid, this is a pyramid, correct? You draw the vertical projector line. You draw a vertical projector line like this. Let me show you in the next the slide. You draw a vertical projector line, that is the axis of your pyramid, and take what is the height of the rectangular pyramid. So it is 60 millimeter. Correct? 60 millimeter. How much it is? It is 50 millimeter. Yes. So you draw a line passing through the center which is equal to 50 millimeter. So this is the vertex or the apex of your rectangular pyramid. Okay. So once you get the apex or the apex or the vertex of your pyramid, you join all the corners of your this apex or the vertex of the base of your rectangular base. So how it looks? See, joined all the corners to this apex till here. Now your isometric position of the both the combination it is ready. At the end, what you have to do? You have to highlight only the visible edges. Okay. So the base rectangular slab, which I have shown in the pink colors, only till here you have to make these edges as the visible edges, and then the top, the rectangular pyramid you can see here. So only these the blue color which I have highlighted, only those the lines you have to make it visible edges. The rest of the lines, so this is a construction line. At the end, you can erase it. Okay, which I have not done here, just to show you here. Only these lines you have to highlight. That's all. Okay. So I hope you understood this also. So total 4 examples we have discussed today. So today itself you complete it, and also the PPT also have shared in the edit. You go through that. Any doubts? Okay, you can feel free to contact me so that I can help you.